Now, I've already told you that I know exactly what the problem is here, but let's pretend that we don't know what the issue is. And one of the things we would like to do is try and find out why this application is running out of memory. To do that, we'll use an application that allows us to view the stack and the heap, and this application is called JVisualVM. If you're using the Oracle JDK, and I've actually navigated here to the Java 8 Oracle JDK that I've got on my machine. If we go into the bin folder, you'll find the JVisualVM is an application here that you can just run. If you're using the Open JDK, then JVisualVM doesn't come as part of the standard JDK. You won't find it in the bin folder. But it is a freely available downloadable application that you can get from the website I've got on screen here, which is visualvm.github.io/download.html. This is actually an Oracle project, although Oracle have released it under the GNU version 2 license with class-path exception, so it is absolutely free for you to download and use. You might notice if you read the screen that actually what you're downloading is the Oracle JDK 8 version of Java Visual VM. That's because from version 9 onwards, they've moved this into something called the Graal Visual VM, and I'm going to talk about Graal later on in this course, right at the end of this course actually, but for now we want to stick with Visual VM. So you can download the zip file if you're using Windows or Linux, and then unzip the file and you'll find the runnable application in there, or if you're using a Mac, there is a Mac version you can just download and install. So whichever version you're using, we'll start JVisualVM by double clicking on it, and if you are using Windows, at this point, you might have an issue, which is an error message saying that JVisualVM cannot detect local applications. Now, I'm not getting that problem because I've already fixed it. Actually, it's the same problem that we saw earlier on this course, and so fixing it earlier has fixed it for this. I'm going to just repeat it, however, in case you weren't following that part of the course and you are seeing a problem now. You need to make sure that your hsperf data folder is readable. This folder is a little bit hidden. You'll find it under wherever your standard users folder is under your username. There'll be a structure under there called app data, then local, and then temp. And then under that will be a folder called hsperfdata _ followed by your username. Again, right click on it and choose properties, go to security, and make sure that you've set everyone to have either modify or full control. If you've done that, then JVisualVM will work without any problems. Okay, so I've started JVisualVM here. I'm just making the window a bit bigger. And on the left-hand side, under local, what we'll see is a list of any applications that are running on my machine that are running Java that I can connect to with the JVisualVM tool. At this point, my application isn't running, but I have got a reference here to Eclipse, so we could use JVisualVM to connect to that. And actually, VisualVM, of course, is a Java application, and we could connect to that if we really wanted to. But just so we can explore JVisualVM, let's connect to Eclipse. So we need to select it and then right-click and choose Open. And on this first screen is an overview that tells us a little bit of information about this running applications. I think the maybe interesting things here are we are told the maximum heap size for Eclipse is 1 GB and the initial heap size is 256 megabytes on this machine. On your machine, that might be different, of course. So what this means is that if Eclipse at any point needs more than 1 GB of heap space, then Eclipse is actually going to crash. Now, I think it's very rare for Eclipse to crash. I don't think I've ever seen it happen, which of course means then that Eclipse hopefully is a well-structured, well-running application that stays within the memory bounds that it says it needs, which in this instance is 1 GB. Let's go now to the Monitor tab, and this has a number of graphs, and I'm particularly interested in this one at the top right, which is called heap. In fact, I'm going to close the other graphs just so that we can see heap in more detail occupying the screen. And what we've got here is the used amount of heap in the lower part of this graph in light blue, and the total heap is represented by this yellow line. So it looks like we've got something around about 270, maybe approaching 300 megabytes of heap spaces currently in use. And even though we know that the maximum heap space that Eclipse is allowed to have is 1 gigabyte, actually the most it's ever used, or it's been resized to, looks like it's about 550 megabytes at the most. In fact, actually it tells me up here, look, it's 558 megabytes. Now Eclipse, even though I'm not doing anything with Eclipse, must be doing something in the background because it's using more and more heap space over time. This slow upward gradient is telling us that more and more heap space is being consumed. And if we see that drop, then that tells us that there's been a garbage collection and it's been released. I'm going to leave this to run for a little while off camera and then press resume in a moment or two. Okay, well, I've just pressed resumed, and as you can see, we've had a dramatic change here. The amount of the available heap has decreased significantly, and in fact, the total heap has decreased partly as well. So what that tells us is that at this point in time, there was a garbage collection. And because of the garbage collection, a number of the objects were cleared out of the memory. The amount of memory that Eclipse needed has significantly gone down. And that tells us that Eclipse is running as a very balanced, managed application here. Because while nothing is happening, we're not seeing an unmanageable increase in heap size. And clearly the objects that Eclipse is creating are able to be released over time. So it looks like there is a stable level of memory that Eclipse requires. And in fact, that is the ideal. We want our applications when they're running to show this kind of graph, that they're balanced, that they're well behaved. They're not grabbing too much memory so that there isn't enough available for our other applications.